All right, let's tackle a huge question today, one that's on pretty much everyone's mind. Is AI actually thinking? We're about to dig into a really radical framework that says the answer is a hard no, and that we've been looking at the entire problem from the wrong angle.
I mean, you've seen it, right? It's impossible to ignore. The AIs we're all using can do these incredible things. They compose music, they write lines of code that actually work, they create jaw-dropping art. Their behavior feels so, well, intelligent. So the question we're all asking is pretty obvious. Have we finally done it? Have we built a thinking machine?
But what if the answer isn't just not quite or almost there? What if the answer is a firm, definitive no? This framework argues that today's AI, with all its amazing talents, is structurally incapable of real thought. Not just now, but ever, in its current form.
So, to really wrap our heads around this, we have to stop looking at what an AI does. You know, the poems, the code, the art, and we have to start looking at what it is. We've got to peel back the curtain on its captivating behavior and stare right at its fundamental architecture.
Okay, so let's dive in. At the absolute heart of this whole argument are two completely different ways of thinking about intelligence. You could almost call it a tale of two AIs, the ones we have now and the ones this framework says we should be trying to build.
So on the left, you've got stochastic machines. That's today's AI. Think of them as incredibly sophisticated guessing engines, basically. They're always just predicting the next most likely thing, whether it's a word or a pixel. They imitate cognition. But over on the right, that's the goal, a synthetic mind. And this isn't about guessing at all. It's about having a stable, predictable structure, kind of like a building's blueprint. It wouldn't just imitate thinking, it would actually embody it. And this quote right here, it just flips the script completely. It says, the real test of a mind isn't how clever its answers are. It's about stability. It's about the ability to hold your internal structure together when you're under pressure, when you're facing a contradiction. It's really about being able to remain yourself. So if it's all about architecture, then what does that architecture actually need to look like? What are the non-negotiable building blocks for a mind, at least according to this model? Well, it turns out there are three core components we really need to understand.
First up is something called topology. Now forget the complex math for a minute and just think of it as the mind's blueprint. It's the fixed roadmap of a city or the internal layout of a building. It defines all the pathways and it shapes how everything flows through the system. It's a stable, underlying geometry.
Okay, next we have load. Now, in this model, load is what drives cognition. It's not just data being processed, it's pressure, it's stress, it's a demand. You can think of it like the weight a bridge has to support, or the force of the wind against a skyscraper. It's the thing that forces the architecture to actually deform and react. No load, no thinking. And that brings us to the third piece, coherence, which is basically the structural integrity that holds the whole thing together. So when that load hits the topology, does the mind bend or does it break? Can it maintain its essential shape? That ability to deform under pressure but remain stable, that is coherence. So now that we have these three key ideas, topology, load, and coherence, we can see with crystal clarity why today's AI systems just completely fail this test of being a true mind.
So here's the breakdown. Current AI doesn't have a fixed blueprint, no topology. It just has a massive sea of adjustable numbers or parameters. It doesn't experience load that deforms a structure, it just processes probabilities. And because there's no fixed structure to begin with, there's no coherence it needs to maintain. There's literally no self there to hold on to.
This quote just puts it perfectly. Today's AI is just mimicking the residue of cognition, the words, the pictures, the stuff left over, without having any of the underlying machinery, the actual cause of thought. It's like seeing smoke without any fire. So, if the AI we have now is just a really good simulator, what would a true synthetic mind look like when it's in action? I mean, how would it actually work if it's not just predicting the next word in a sentence? See, in this model, thinking isn't some kind of magic that happens in a black box. It's a clear, almost physical process. You start with a stable structure, let's call it state A. You apply load, some kind of pressure, and the structure predictably deforms and then settles into a new stable shape, state B. That journey, that transition, that's the thought. So the whole process looks something like this. First, you start with a defined architecture, your topology.
Then you apply pressure to it, the load. The system then deforms, but because of coherence, it holds itself together and transitions to a new stable state. And then, only at the very end, like a final echo of that whole internal journey, do you get behavior.
This is probably the most counterintuitive and maybe the most powerful idea in this entire explainer. It means that everything we currently use to judge an AI, how fluent it is, how creative it is, how well it can hold a conversation, is actually the least important sign of whether it's actually thinking. The only thing that truly matters is the stability and integrity of its underlying architecture.
And that really leaves us with a fundamental question for the future, doesn't it? Are we just chasing machines that get better and better at imitating us, at sounding intelligent? Or should we maybe be focusing on the much, much harder problem of building systems that are truly structurally sound? That's the choice this framework really puts on the table.